Prior to standardization of the network industry, many systems had their own method of communication. Networking standards had to be developed, and the ISO introduced the OSI model, commonly known as the 7-layer model. The 7-layer model offers many benefits. Here are a few. The 7-layer model is a conceptual model used to describe standards of communication functions within a networking system. The upper 3 layers, the application layers, focus on the programmatic functions of network systems. The lower 4 layers, the data flow layers, focus on the networking or data flow of network systems. The transport layer, or layer 4, is the primary interface between the programmer and the networker. Here are the upper layers of the 7-layer model. Here are the data flow layers of the 7-layer model. Host-to-host communication, often referred to as peer-to-peer communication, sends data from a host to the corresponding layer on another host, or horizontal communication. Because connectivity occurs at the physical layer, the data must be programmatically moved down the stack layers, sent across the physical layer, and sent up the stack layers on the receiving device. This is called vertical communication, and is often referred to as encapsulation down the layers and decapsulation up the layers, or stack. The upper layer, or application layers of the 7-layer model, generate data. The generated data is handed down to the transport layer, where it is divided and encapsulated into segments. Segments are passed down to the network layer, where they are encapsulated into packets that are addressed with the logical address of the destination. Packets are then passed down to the data link layer, where they are encapsulated in frames that are addressed with the physical address of the next device in the network path. Finally, the frames are converted to bits, which are most commonly represented as either 1s or 0s and sent across the media. On the receiving device, the opposite occurs. At the physical layer, the bits are collected into frames, and the frames are passed up to the data link layer. The packets are removed from the frames and are then passed up to the network layer. From the network layer, the segments are handed up to the correct transport layer. Finally, the transport layer hands the data up to the correct application. The TCP/IP model is the most common protocol stack. It is what operates on the Internet. Now, take a moment to compare the TCP/IP protocol model against the OSI model. The OSI model layers 5 through 7 map to a single TCP/IP application layer. This application layer is often referred to as layers 5 through 7. The OSI model layer 4 maps to the TCP/IP transport layer, which is often referred to as layer 4. The OSI model layer 3, or network layer, maps to the TCP/IP internet layer. This is why the World Wide Web is called the Internet, because it operates at the internet layer in the TCP/IP model. Note that the internet layer and its addressing is often referred to as layer 3 IP addressing in order to differentiate it from layer 2 MAC addressing. The OSI model layers 1 and 2 map to a single TCP/IP network access layer, or link layer. Click Next to continue. As the data moves down the stack, encapsulation occurs, and each layer defines a PDU. The application data produced by the upper layers can be very large, so the transport layer often needs to break up the data into smaller segments so that it will fit into individual packets. The transport layer then prepends a transport header, which includes an application or port number. When the segment is passed down to the network layer, the packet header is prepended with the logical address of the destination. The packet is sent down the data link layer. The data link layer might prepend an LLC header to provide for acknowledged delivery of the frame if needed, but will prepend a MAC header and an FCS trailer to the frame. The frame is sent over the media as bits. Click each button to explore an example of data encapsulation. The user types an email message, and the email application generates data. The data is passed down to the transport layer, where the segment/TCP header is prepended. The segment is passed down to the network layer, where the network/IP header is prepended the packet. The packet is passed down to the data link layer and is encapsulated into a frame with a frame header and a frame trailer. The frame header and frame trailer become ones and zeros, or bits at the physical layer, and the bits are sent over the media. What happens when the data is decapsulated? Click the buttons from bottom to top to explore a data decapsulation example. The MAC header and FCS trailer are verified and removed. If there is an LLC, it is inspected and removed. The packet is then passed up to the appropriate IP layer, either IPv4 or IPv6, where the IP header is inspected and removed. The segment is then passed up to the transport layer, where the TCP header is used to verify flow control, perform error checking sequencing, and evaluate the segment for possible retransmission. The data is then sent up to the correct application, resulting in an email.